Today's lesson is about determining limits using algebraic manipulation. But to start, we're going to start with 4 special trig limits that you need to memorize. So, first one is limit as x approaches 0 of sine x over x. So we need to memorize that this equals 1. And then very similar to that, the limit as x approaches 0, if you just flip it, of x over sine x also equals 1. And then the other two, limit as x approaches 0, if you have 1 minus cosine x over x, this equals 0. And then last one, the limit as x approaches 0 of cosine x minus 1 over x equals 0. So these 4 you need to simply memorize. All right, first example, I'm going to look at the limit as x approaches 5 of x squared minus 8x plus 15 over x squared minus 3x minus 10. So let's see what happens if we were to do direct substitution. That's what we're used to, is just, hey, plug in 5 for x. So 5 squared minus 8 times 5 plus 15. And then looking at 5 squared minus 3 times 5 minus 10. If you evaluate this, you're going to end up getting a 0 over 0. Well, can't divide by 0. So what this is saying is the function at 5 is undefined. That doesn't mean that the limit is undefined. For example, if we have a graph, maybe at x equals 5, it is undefined. There's a hole in the graph, but there's still a limit. Both the left and the right sides are approaching the same value. So what we can do is do the factor and cancel method. So what we're going to do is factor our rational function and then see if anything cancels. So let's look. I've got the limit as x approaches 5. If I factor the numerator, I'll have x minus 3 times x minus 5. And if you factor the denominator, you'll have x plus 2 times x minus 5. So now the x minus 5 cancels. So now I can, let's see, the limit as x approaches 5 of x minus 3 over x plus 2. After I factor and cancel, I can now do direct substitution, plug in 5. So 5 minus 3 is 2, 5 plus 2 is 7. So as the x value approaches 5, the y value approaches 2/7. Okay, and here is our second example for this method, factor and cancel. If I'm looking at the limit as x approaches 0 of sine x over 2x squared minus x. So because I see that trig, let's think about those ones that we had to memorize at the very beginning. But if we look at my denominator, I can factor that. So let's do that. Limit as x approaches 0 of sine x over, factor an x out, so 2x minus 1. Well, the limit as x approaches 0 of sine x over x, so that is 1. And if I plug in 0 to what is remaining, 2 times 0 minus 1 is negative 1. So then the limit is equal to negative 1. All right, so the next method, we're looking at rationalizing square roots by multiplying by conjugates. So here's an example. Limit as x approaches 0 of the square root of x plus 4 minus 2 over x. So as is, if I plug in 0 in for x, I'm going to get an undefined value. So it might be undefined at that point, but we can still find the limit. So in the box to the right on your notes, we're going to use that to kind of do the algebra. So if I look at square root of x plus 4 minus 2 over x, I'm going to multiply by the conjugate here, which is the square root of x plus 4 plus 2 times the square root of x plus 4 plus 2. So multiplying top and bottom are the same. So if I FOIL the top, when you're FOILing and you're multiplying conjugates, you only have to multiply first and last. So square root of x plus 4 times the square root of x plus 4 will leave you with just x plus 4. And then negative 2 times 2 is minus 4. All over, I'm just going to leave this as x times the quantity square root of x plus 4 plus 2. So what happens here, 4 minus 4, and x over x. So if I go back here, I'm going to simplify this down to limit as x approaches 0 of 1 over square root of x plus 4 plus 2. So now that I've simplified, I can now substitute my 0 in. 0 plus 4 is 4, square root of 4 is 2, 2 plus 2 is 4, so it is equal to 1/4. Okay, the last example is when we have complex fractions. So the limit as x approaches 0, let's look at 1 over 2 plus x minus 1/2 all over x. So just like the other ones, if I do direct substitution right away, I'll have an undefined value. So how do I calculate the limit? Just like the last example, we're going to use our second box for our our simplification, our algebra. So if I'm going to rewrite this, 1 over 2 plus x minus 1/2, and I'm dividing by x. So first here, let's get a common denominator. I'm going to multiply this here by 2 over 2, and then multiply over here by 2 plus x, 2 plus x. So what I'm going to have is the denominator of 2 times 2 plus x, and then numerator 2, and then minus 2 minus x. And then instead of dividing by x, I'm going to multiply by 1 over x. So let's see what happens. 2 minus 2, and then x over x. So if I go back here, the limit as x approaches 0, don't forget that subtraction sign is going to turn into a negative 1 over. 2 times 2 plus x. So if I substitute a 0 in, 2 plus 0 is 2, 2 times 2 is 4. This ends up equaling -1/4. So there is your full lesson on using algebra to determine limits, complex fractions, rationalizing radicals, factor and cancel, and then those special trig limits. Good luck with your lesson.